MS Ramaya University of Applied Sciences.
Dear students, today we will be studying about how to perform arithmetic operation using 8051 microcontroller. As a first step, let us study about Intel 8051 microcontroller, which is an 8-bit microcontroller. It means that most of the available operations are limited to 8 bits. It also means that it can take 8 bits of information at a time, process it and gives the output. And most of the registers present in microcontroller 8051 are 8 bit. It is also called as 8-bit microcontroller. Now let us discuss some of the major features of 8051. It has 8-bit arithmetic and logical unit ALU. It has 34 general purpose registers GPR, which are 8-bit each. It has two 16-bit register program counter PC and data pointer DPTR. It has 128 bytes of internal RAM and 4 kilobytes of ROM. It has 8-bit data bus and 16-bit address bus. It has 8-bit PSW, processor status word. It has 4 8-bit ports and 32 input-output ports. It has 5 interrupts and 8-bit asynchronous serial communication. So 8051 chips are used in a wide variety of control systems applications, telecommunication application, robotics application as well as in automotive industries. They can perform the arithmetic operations such as addition, subtraction, multiplication and division. So in order to add the two numbers, we use this addition operation. The instruction used is add a, source. So where A, the position of A is the destination, the source can be immediate data, indirect data or the data present in the register, but the destination must always be accumulator. Once the addition operation is done, the result will be stored in accumulator. In order to subtract two numbers, we use this subtraction operation. The instruction used for subtraction operation is SUBB A, source, where SUBB represents subtraction with borrow. There is no subtraction, just subtraction operation in microcontroller. The only operation present for subtraction is subtraction with borrow. So SUBB, where A is the destination and source. Here also the source can be immediate data, indirect data or the data present in the register, anything, but the destination must always be accumulator. Once the subtraction operation is done, the result will be stored in accumulator. In order to multiply two numbers, we use multiplication instruction. The instruction used for multiplication is MULAB. Once the multiplication is done, the result will be stored in register A and register B. To divide the two numbers, we use the instruction DIV-AB. The result obtained for division will be in the form of quotient and remainder, where the quotient will be stored in register A and the remainder will be stored in register B. Thank you.
Hello students, today in this session we will be studying about how to write an assembly language program using 8051 microcontroller kit. Latest required for this programming are 8051 microcontroller kit. So this is the 8051 microcontroller kit. The microcontroller kit consists of 8051 microcontroller IC, which is a 40-pin IC. All these pins are internally shorted and they are bought out here for external connection. And this is 8253 IC, which is for your timer interfacing. And these three are 8255 ICs, which are programmable peripheral interfacing ICs. These ICs are bought internally connected and bought out here for external connection. So this is the serial communication port, which is to connect RS232 pin here. And this is the power supply. So this is the USB connector in order to connect the keyboard, and this is the LCD display. So this is the reset button. Once you press this message will be displayed on your LCD screen. Power supply. So this is the power supply which will be connected to the board. Once we start with the experiment, we'll switch on this mains and keyboard. So this is the keyboard. These highlighted keys are the main keys in which we will be using for programming. So now let us understand how the addition program can be written in ALP using this kit. Before to start with, let us switch on the power supply. Now let us start typing the program in the kit. Now let us start typing the program for addition of two 8-bit numbers. Before to start with, give A, and from which memory location you want to start, give that memory location, give enter, then start writing your code from here. Move A, hash 4. So I am loading my accumulator with the value 4. Give enter twice, then move R1, hash 6. So I am now loading my R1 register 1 with value 6. Give enter again. Then add A, R1. Give enter so that your result will be stored in your accumulator. Now give lcall space 0003. Then give enter. Once this is done, give reset. Click on go, then enter the memory location from which you have started your program. We have started our program with 8000 H memory location. Provide that there and give enter. So it shows program executed. Once this message is shown, press enter once again. Now it is asking select any one key, whether it is in assembler mode or disassembler mode. It is asking this way. So our result is in the register which is accumulator. So press R. It is asking which register. Now click on A. So register A is having the value 0A. That means we have done the hexadecimal addition, which is the addition of 06 and 04, which results in 10. So hexadecimal value in 10 is 0A. Now let us start with the subtraction of two 8-bit numbers using 8051 microcontroller kit. So to start with, press A and give the memory location from which you need to start your program. So let us enter 8000. Now start typing your program. Move A, hash 6. Enter, type enter twice, then move R3, hash 3. Enter. Then give the command as subb A, R3. So this command is subtract with borrow. In 8051 there is no instruction like just subtract. So along with the borrow we are taking, so the command will be subb, and always the destination should be your accumulator so that the result will be stored in your accumulator for addition as well as subtraction. Then give enter. Once this is done, again give lcall space 0003. Give enter. Once this is done, now we need to reset. Once we reset the program, then give go. From which address location we have started our program, that address should be mentioned here, that is 8000. Give enter. It shows program executed. Once the program is executed, give enter one more time. Again it is asking where your result is displayed. So our result is in the register. That is why give R. It is asking for which register. As I have told you, our result will be in accumulator register. So click on A. So we have given 6 minus 3, so the answer is 0, 3, and it is stored in the register accumulator. If we want to check other register, then click on next so that you can see other registers also. Now let us start with the multiplication of two 8-bit numbers. In order to start with the multiplication, we should be knowing that always the source and the destination should be accumulator and the register B itself. So now to start with, press A, provide the address location from which you need to start, press enter. Then give move A, hash 7. Enter twice, then again type move space. So there is no provision in 8051 kit to give the value of register B directly. So instead of typing B, we should give its address, that is 0F0. 0F0 also means register B itself, which is the address of register B. So 0F0, hash some value 5. Enter twice. Then MUL is the instruction for multiplication of two numbers. So MUL A, B. Give enter. Once this is done, give L call space 3. 0003. Then enter. Then reset. Then type go and provide the address location from which you have started, that is 8000. Give enter. It shows program executed. Again press enter. Then it will ask where is your result. Give R. Then which register it is asking, it will be stored in register A first. So the result is stored in register A. Suppose if the result is exceeding the 16-bit number, then it will be in register D. So now let us start with the division of two 8-bit numbers. In division also, always the source and the destination should be register A and register B itself. So now to start with the program, press A, provide the address location from which you are starting, that is 8000, enter. Then start typing your program, that is move A, hash 5, enter. Enter twice. Again move space. There is no provision in the kit directly to give B register, that is why we need to give the address of B, which is 0F0, hash 2. Enter. Then div space AB. Enter twice. Then give L call space 0003, enter. Once this is done, give reset. Then press go and provide the address location from which you have started, which is 8000. Enter it. It shows program executed. Press enter again. It will start. It will tell to select any one key. So press R. It shows which register. So give A. So in A, our result is stored, and click on next so that the quotient will be stored in A and the remainder will be stored in B. So this is how we realize the assembly language program using the 8051 microcontroller kit. So this experiment is completed, that is arithmetic operation, all addition, subtraction, multiplication and division of both two 8-bit numbers are completed.
At MSR UAS, we spark your imagination unlike any other.